So if you recall at the end of the last session, we'd been talking about concurrent programming concepts. And what we're going to do now is we're going to start talking about how concurrent programs are developed in Java. This will be a light overview, and it's really not the focus of the class per se, but I want you to have a good holistic perspective. And this is also kind of a teaser for other things we would cover in my sibling course, CS 254. So we'll talk about how Java supports concurrent programming, the concepts we talked about last time. We'll talk first about thread objects, including something called Project Loom, which is looming on the horizon. And then in the next section, part 2, we're going to talk about ways that threads interact in concurrent programs with Java. So what is a thread? In Java, a thread is an object. Like almost everything else in Java, there's a few minor exceptions, especially with super modern Java. There are things like records and lambdas that aren't really objects per se. But a thread is an object. And this is the definition from the Java thread class documentation. A thread is a thread of execution in a program. It's kind of funny defining a term in terms of itself, but think of it as a way to have a stream of instructions that are processed within a program. And the Java virtual machine, or the execution environment, which is not always a virtual machine, allows an application to have multiple threads of execution running concurrently. That's really the key point from this particular piece of documentation. And then it talks also about some other things related to threads, and we'll talk about those in a second. So a thread contains a bunch of methods. This little class diagram here is just a small snippet of the methods that are involved in threads. There's lots and lots and lots of methods. And it also contains internal fields. These are not things that you would see as a programmer. You can't really access them. They're private. However, they're used for various things that you'll learn about if you learn more about threads. For example, threads have priorities, threads have names, threads are runnables, threads can be daemons, threads can have a stack size, threads can have an ID, et cetera, et cetera, et cetera. And again, we're not going to talk a whole lot about that. I just want you to be aware that a thread is an object like many other objects you have come to know and love in your programming experience. Historically, each Java thread had its own unique ID, so that gives it a unique identity, like thread 7 or thread 10. It can have a name. If you can give it a name if you want, or it'll be given an internal name. It has a priority. Priority just means that if you have multiple threads that are ready to run, the one which has the highest priority should be the one that will be running before the ones of lower priority. It's got a runtime stack. That's what's shown here. Runtime stack, as you may recall, hopefully you've learned a bit about stacks somewhere along the way. That's what's used to keep track of method calls in Java. It enables recursion, for example, among other things. And it also has something called thread local storage. Won't talk too much about that right now. An instruction pointer to keep track of where it is in the stream of instructions it's processing, and other registers and so on. So that's what a thread is in a nutshell. And as you can see, you can have multiple threads, and the Java runtime and the underlying operating system cooperate in order to implement this semantics. Now, in forthcoming versions of Java, hopefully not too distant from now, there's going to be a bifurcation of the threading concept. So traditional Java threads in this super duper modern Java will now be called platform threads. And those are what we would think about as the traditional threads, the ones we just talked about here on the previous slide, where we had the concept of a runtime stack and so on. They'll now, in modern Java, be something called virtual threads, which are lightweight concurrency objects. And I'll talk a bit more about those in a second. You'd really have to go look at the documentation for Project Loom to learn more about this, but I'll give you a quick overview. It's really going to be interesting when this finally gets released into the wild, into the mainstream Java version. Threads can also be in one of various states. So these are the states that a traditional Java platform thread can be in. And I'm not going to go through this in great detail, just a quick summary. So when a thread is created, when you say something, new thread object of some form, then an object is created, but it hasn't really begun running yet. When you say start on a thread, that makes the thread runnable. And when a thread is runnable, then it's capable of being run by the underlying operating system and Java thread scheduler. So at some point, the thread scheduler will choose to make the thread run or running. And does anybody know why when a thread is started, it just doesn't start running automatically. Do you know why that's the case? The reason for that is that there could be lots of other threads that are ready to run at the same time, but there's only a certain number of cores, and there's often fewer cores than there are threads. So something is runnable means it's in the queue waiting to run, and when it's running, it's actually on the core running. And then there's a bunch of other little things that'll happen. When a thread is running, its run hook method is being called, and then it can go into different states. If you wait, you'll be in the waiting state. If you do something that attempts to access a guarded resource, like you go into a synchronized method or synchronized statement, then you'll be blocked. There's things called timed waits. The thread can sleep. It can join, so it'll be waiting in a timed wait state. And depending on what happens, once you're out of these different states, you go back to being runnable and then running. And then at some point along the way, the run method returns, and it either returns because the flow of control fell off the end of run, or an exception was raised that was not caught in the context of run. In any event, the thread will be terminated and it'll go away. So that's a quick summary of thread states. Why do you care about this stuff? Most of the time you don't care about this stuff. The only time you'd really care about this stuff is if you were debugging a multi-threaded program and something went awry, and you look in the debugger and you figure out, oh, my thread is in the blocked state. And that might give you a hint. For example, maybe you've deadlocked on something, which could possibly happen. So that's why it's sometimes useful to know what Java thread states are. With these modern Java virtual threads, which are still just a little bit over the horizon, although you can play around with the early access versions if you really want, they have a bunch more states. And the reason why they have a bunch more states, as we'll learn about as we get further into this, is they don't have their own runtime stack. They share runtime stacks. And so as a result, they're in a different set of states. And this is really, really cool stuff. And it leads to something that's known as structured concurrency. And if you want to watch some more videos about Project Loom and modern Java threads, please take a look at the link at the bottom of the slides, and you'll learn more. So that's the end of the quick overview of Java threads in Java. And now we'll go and talk about the next concept, which is how threads can interact.